EV Expert, e-learning, diagnosis. Isolation breakdown. Overview. The 12-volt low-voltage battery of an EV is grounded through the body, and it drives various electronic devices of the vehicle. As an EV uses 12-volt low-voltage power as well as high-voltage power, the high-voltage circuit is designed to be completely isolated from the low-voltage circuit. If isolation breakdown occurs, the driver or technician can be exposed to dangerous high voltage. The EV is designed to monitor the circuit isolation status at all times and to notify the driver or technician if an abnormality is detected. BMU is the controller that monitors the isolation breakdown. With the Kona EV, if the insulation resistance is less than 300 kiloohms for approximately 2 minutes, 108 seconds, it displays a DTC to warn the driver or technician of the risk. After making the EV off state, the warning light disappears when re-entering the EV ready state, but after some time, the same symptoms occur again. Therefore, if a customer visits a service shop after finding these warning lights, there is a high probability that there is no active DTC due to the restart of the EV, so the DTC history must also be checked. Now let's try inspections and maintenance on vehicles that actually have these problems. First, check the DTC with GDS. Select Fault Code Searching on GDS. An isolation breakdown is monitored by the BMS. Select BMS. And enter the DTC check. P0AA600 Hybrid EV Battery Voltage System Isolation Fault. Active DTC is found. Since the DTC is confirmed, let's try to check the symptom in detail. Select Software Management. Go to Battery Control and select Isolation Breakdown Detection Function. Confirm the Enable condition and select OK. This test is conducted in 3 steps as follows, and if there is no problem, it takes about 5 minutes. Step 1. Check the high voltage battery system isolation condition under the PRA main release off condition, high voltage battery unit. Step 2. Turn on the PRA main relay and expand the inspection area to the high voltage input circuit to check the isolation condition, high voltage input unit. Step 3. Activate the motor inverter and check the isolation condition, motor 3 phase unit. Isolation breakdown. Diagnosis procedure. The process identified isolation breakdown at the high voltage input unit area. So now, let's check the insulation resistance of specific areas. Select Software Management on GDS. Then select Inspection of Insulation Resistance of High Voltage Parts in EV from Battery Control. Confirm the Enable condition and select OK. Don't forget, the test time can be set for each area of the high voltage circuit. Earlier, it was already confirmed that isolation breakdown failure occurred in the high voltage input unit area. Therefore, let's set the inspection time sufficiently for this area to check resistance value in more detail. OK. First, the high voltage battery part is being checked. As the insulation resistance of the high voltage battery did not drop and remains higher than 300 kilo ohms, the high voltage battery is normal. OK. Now, as the PRA turns on, check the resistance, including the high voltage input unit. The insulation resistance gradually decreases and reaches 0. This confirmed once again that the insulation resistance in the high voltage input unit area was destroyed. Now it is time to check the AC compressor, PTC heater, and three-phase motor in order. After checking each condition, start the test. Then you will see the resistance change as shown now. This is because the isolation breakdown of the high voltage input unit area also affects the parts behind it. Therefore, these parts should be checked again after fixing the high voltage input unit area first. Let's now identify the exact location of the defect using a megohm tester. Since the trouble has been identified in the area from the main relay to the high voltage input unit, all areas shown in the figure should be checked. In the EV off state, the main relay inside the PRA is turned off. Here, if the quick charge relay is turned on, the high voltage circuit is connected from the rear end of the main relay of the PRA to the charging inlet. In this state, the isolation condition between the charging inlet DC terminal and the vehicle body can be checked. So, let's first measure the insulation resistance of the charging inlet DC terminals and the body with the quick charge relay open. It is open loop, so the high voltage line connecting the charging inlet and the high voltage junction block is normal. Now, after turning on the quick charge relays of the high voltage junction block, check the condition between the charging inlet DC terminal and the vehicle body. The insulation resistance of the charging inlet DC minus terminal is open loop. It is normal. The insulation resistance of the charging inlet DC plus terminal is abnormal. Then you should narrow down the trouble area. First, remove the PTC heater cable on the high voltage junction block and measure the insulation resistance. As a result of the measurement, there is still a problem. Next, remove the high voltage battery cable of the high voltage junction block and measure it. It is measured normally at both charging inlets plus and minus DC terminals. Therefore, there is a trouble between the high voltage battery cable and the rear end of the PRA main relay. Now, remove the high voltage battery cable and check the main terminal on the battery side. It is normal and there is no trouble from the rear end of the PRA main relay to the main terminal of the high voltage battery. Finally, measure the high voltage cable. It is normal in minus DC terminal. But isolation breakdown is found in the plus DC terminal. Therefore, the trouble occurred in the high voltage battery main cable, and the cable should be replaced with a normal part. Now replace the defective cable. As a result of checking the defect cable, the noise shield line and the high voltage plus DC line were short-circuited with each other, and the vehicle was operating normally after replacing the new cable. To make sure it is fixed well, let's check the insulation resistance again. Select Software Management on GDS. Then select Inspection of Insulation Resistance of High Voltage Parts in EV from Battery Control. Confirm the Enable condition and select OK. Adjust the test time. Since the vehicle has been repaired and is in normal condition, set a short inspection time. First, check the high voltage battery part. The resistance is 3,000 kiloohms, so no trouble is found. Second, check the high voltage input unit. Then, check the AC compressor part condition and check that the air conditioning compressor status is on. The resistance is 3,000 kiloohms, so no trouble is found. If there is a problem, it will drop. Then, check the PTC heater part condition and check that the PTC heater status is on. The resistance is 3,000 kiloohms, so no issue is found. Next, check the three-phase motor. This test requires driving at least 20 kilometers per hour or more, so it must be done where it is possible to drive. Now start driving. If the speed remains above 20 kilometers per hour, the measurement begins. Currently, it is 3,000 kiloohms without any change. If you are inspecting the defective vehicle, it is recommended to set the inspection time sufficiently. So far, all insulation resistance values are normal. So far, you have learned how to diagnose isolation breakdown and fix the problem.